Hello all. Today in this video lecture we will see non-perpendicular parallel components. In our previous lectures we saw perpendicular components and we also saw non-perpendicular oblique components. Here in this video lecture we will see non-perpendicular parallel components. So for that what we will do, we will consider this point A, and at this A point this F force is acting, and we will resolve this F force like parallel component. So here what we will do, at line 1 1 we'll resolve this force as F1, and here at line 2 2 we'll resolve this force as F2 force. So this F1 and F2 are resolved forces of that F force. So, and what we will do, we will consider O point here, O point, and this O point will be like this, perpendicular to that forces. And what we will do next, we will consider this distance, OA distance we will consider is x, and consider this point as B and this point as C. So OB distance we will consider x1, and OC distance we will consider x2. So just see, this F is force and F1 and F2 are parallel component of these forces. So either way you can call it as F as a resultant of F1 and F2. So resultant, that means addition and subtraction of that F1 and F2 is nothing but the F. So this F is equal to F1 plus F2. F force will act as a resultant of F1 and F2. So you all know that we learn Varignon theorem. So what is Varignon theorem? In Varignon theorem we learn that components movements at a particular point. So here we will consider O point. Components summation of components movements is equal to resultant movement at that same particular point. So see what will happen here. Movement at B plus movement at point O. See, movement at point O, and what movement? About B movement plus movement at point O, which movement? C movement. See, that means this F1 portion, either we will write like that directly, F1 into this force is, see cursor of my pen, this F1 force, and perpendicular distance between that F1 force and that O point, because we will take moment at O point. So perpendicular distance between that F1 force and that O point is distance is x1. See here, this is x1 distance. So F1 into x1, it is clockwise rotation, so that force is going through that point O in a clockwise manner. So that's why it is positive. Again plus, now consider this second parallel component F2. This F2 parallel component also makes like going through that O point in a clockwise manner, and perpendicular distance between that F2 force and that point O is x2. So here movement at point O is F2 into x2, and equal to resultant movement at point O. See, this F1 is also passing through that point in a clockwise manner, so F into x. So this is Varignon's theorem, and f1 x1 plus f2 x2 is equal to fx. We will consider this as point O, and what we will do, we will apply minus sign to LHS side, and we will apply minus sign to RHS side also. So minus f1 x1 minus f2 x2 equal to minus fx, and we will consider this as second equation. So in this equation, what we are able to write, if we will know x1, x2 distance, x distance, and f force, then we will calculate f1 and f2 from equation 1 and 2. So this is nothing but the non-perpendicular parallel component. So just see, with the help of this x1 x2 x distance and this f force, this x1 x2 x distance and this f force, we will calculate this f1 f2 parallel component. So this is all about non-perpendicular parallel component force system. So thank you very much.